LabVIEW. LabVIEW can interface to maybe a chemical simulation software, anything which is supporting a OPC technology. So what do I need for OPC? For OPC, first of all, what I'm doing is, can you see my, can you see this OPC server? Because
No, sir.
no, okay. Because in sharing, I'm trying to figure out how to share everything. 1 minute. Screen 1 PBT. Okay.
Rest of the screen you have to minimize or
No, this
close.
this shares applications.
Okay.
In TVR, how it will share the entire. Now, can you see this?
Not yet, sir. It will take time, I think.
Okay. Anyway, what I'll do is I will skip that section. I'll share my main screen. Uh, I'll show it in a different fashion. Okay. In at least, can you see my software screen? Is that visible?
Yes, sir.
Yes, sir.
Can you see the landing gear of an aircraft?
Yes.
Okay. So in OPC, what we do is, in the background, which I could not show you, is a small OPC server which is running in the background. And in that OPC server, I defined data tags like analog 01, analog 02, analog 03, boolean 1, boolean 2, boolean 3. And that OPC server acts as a communication server. So data can be sent to the server and can be read from that particular server. Okay. So in Automation Studio, in the tools section, you have a communication manager here. And if you see here, there is OPC DA and there's OPC UA. Why is OPC important is because OPC is used for communication these signals through a IoT gateway to the cloud and back. So OPC is the backbone. For example, Varroc engineers, they have shifted the entire production to a IoT concept where signals are taken from the CNC machines and through a OPC gateway, these are sent to the cloud, and from the cloud, then the reports are sent to the managers all across the country. So if you see here, I have this OPC and there is a OPC server which is configured here. Then I create groups and then I do the linking. So in my software, I can link various signals from Automation Studio to the OPC server here. So this is the last part of my demonstration. On the right, you can see there are signals of the OPC server, analog 1, 2, 3, 4. All these are signals. Okay. So this is from the automation side of the program. Now I have to launch a second software by the name of, but how will that be visible?
No, let it be. You just tell them and then final simulation they'll see you.
Okay. Okay.
Finally, they'll be able to see the linkages in Automation Studio.
Actually, what I'm doing is from Automation Studio, these signals from the OPC server, I'm sending to a third party HMI SCADA software. Now, the problem with this is I cannot share two applications at the same time in this particular web Microsoft team. If I could share my entire working screen, you could have seen it. But there's another software which I've launched, and on that launched software, there are dials, gauges, which is a SCADA software, and signals are going from Automation Studio to that particular third-party software. But since that is not visible, we'll just go ahead and see a landing gear of an aircraft here.
Take it on the screen. I'm taking video at least.
No, 1 minute. Share. Why this gone off? It shifted to that other screen now. Just give me 10 seconds. Okay, can everybody see my screen now?
Yes, sir.
Yes, sir.
Okay. Okay, now I cannot share those multiple screens with you, but what is happening is from this software, we are taking the data of the piston extraction, certain sensors data. From the OPC server, we are sending it to another SCADA software which is running in the background. And from there, signal data is coming back to my Automation Studio software. But we'll see the Automation Studio screen here. And this is the landing gear of an aircraft. Now in this, we'll see that in the hydraulic section, there's an accumulator which is charging. Once the accumulator charges, you can see that on the HMI screen, there is a green light which has come on, which says the pressure is attained. Okay. Now, a very simple and very good example of meter in and meter out circuits. We teach students that meter in connected from this side, flow is coming from the input section, output section. How do you meter the flow on both sides? And how is it really used in real life? In this section, if you see in the hydraulic section, we have meter in as well as meter out used together. And why is this? If you see in an aircraft landing gear, on the HMI panel, there are two flaps here at the bottom. So when a landing gear has to come out of the aircraft, the flaps have to open up fast. Okay, so this action has to be fast, and then the landing gear and the wheels come out slowly. Okay, so this is a meter in, meter out condition. One moves fast, one moves slow. And in the reverse condition, what happens is the wheels come in fast and the flaps close slowly. It reverses the entire logic. So we use a meter in, meter out condition here to do such type of an action here. So I'll now open the carriage here. You can see the flaps open fast and the wheels are still moving out on the right hand side screen here. The wheels have come out. Now I want to close the carriage. You'll see the flaps will close fast and the wheels will come in slowly. Sorry, the wheels come in fast, the flaps close slowly. Reverse condition here. I'll do this again. Open carriage. And then close carriage. So such type of systems can be built. I cannot share a lot of screens. I had a presentation for how to communicate to IoT. Maybe on another, anyone interested, we can talk later on. We can do a private demo. And
Explain them a theme.
I'll explain a theme 1 minute. Okay. I wanted to show one mechatronics example. Okay, there's another input I had to give is that see we used to be present for SPPO BOS meetings previously, and what has happened is in the implementation phases, what happens is there are certain restrictions put on students. Like for example, a ladder program should not be more than 4 rungs, and in 4 rungs you can't build more than an AND or a OR gate. Whereas the students who came for projects to us build ladders which are like 200, 250 lines of code. I mean, they worked wonders with the same uh, facility given to them. So we should not, put restrictions on these students. I feel so because they are capable of far more. I mean, you don't have to teach them, but if you give them a tool like this in college, they can actually work wonders. So one last circuit I want to show you. That is throwing out. I don't know. That is happening in this online software, no? Like,
Throwing out without asking.
for sure, I was using that other one. Which one? There it was slowing down the thing.
Minimum
PPT is okay.
Minimum is okay, but software they it is throwing out. Memory का problem रहेगा क्या?
No, no. What happens is it is the animation, na? It is capturing frames. तो उसमें problem आता है. Baling machine industrial. Where is it gone?
No, that you go to IoT now. Most of applications been discussed now.
But how do I show IoT? Because
Verbally you tell them and वो paper रहेगा so देर सर करके दिखाओ.
hmm?
Verbally OPC तो बताया आपने तो OPC से भी आप दिखा सकते हैं.
Okay, just one last circuit and one slide of IoT. Just this circuit and one or two slides on IoT, and we'll end the session here. Now this is a circuit of a cotton baling machine. Okay, if you see the PLC, there's an entire PLC logic here, and that is operating an entire hydraulic circuit here. This is an industry cotton baling machine here.
The PPT is not visible.
So, 1 minute. Yeah, sorry about that. Has it come on?
Now it's okay.
Okay. So if you see, there's a PLC section here. This PLC is controlling the logic for the automated cotton baling machine. It's a mechatronics type of a system here, automated cotton baling machine. So this is a hydraulic system of the circuit here. On the top here, this is the actual where the cotton gets pressed. So one cylinder will put the cotton into the cavity, the other cylinder will press it, then the door will open and it will throw it out. Okay. So let me simulate this. Let's start. You can see the behavior here. So such type of projects have been done by students. And there are a lot of them. So they actually pick up an industry circuit like this, they model it, they build the PLC ladder and they simulate it and it becomes a student project. So there are lots of these circuits available. Like some students, they go to Google, they'll find some company, they'll pick up a circuit, they'll reproduce the entire circuit and the logic. Some will actually go to a company like Eaton, Danfoss or someone, Parker, Hannifin, pick up a particular project from them, recreate it in Automation Studio. So such type of student projects can be done. And before I end the session, just one last thing I wanted to tell you about IoT. There are a lot of IoT sessions happening, I know, in this particular 4-day event. I wanted to point out certain things. Just one slide I want to show you. Is the PPT visible?
Yes, sir.
Yes, sir.
Okay. Yeah. Uh, See, we get a lot of inquiries from teachers as to what do we do with what
PPT
do
is
we
not
do as
visible, sir.
a yeah, 1
P-
minute. I'm just doing something. Yeah, one minute.
PPT.
Just hold on. Just hold on. I'm starting some other things also. Yeah. Okay. Is the PPT visible?
Yes, sir. Yes, sir.
Okay. Uh, we get a lot of inquiries from teachers that what should we do with IoT? Everybody's talking IoT, IoT, IoT. Now in IoT, you need certain key components. One is at the ground level, either sensor data, it could be simulation software, automation studio generating sensor data, etc. You have to capture all this sensor signal. Okay, this sensor signal. This sensor signal has to be captured. Now the backbone for capturing this data, we would recommend using a OPC channel. So if you buy a PLC from the market today, you get something, for example, if you have an Allen Bradley PLC, you get an Allen Bradley OPC server, which you can buy from the same company. Each and every PLC manufacturer in the world has a OPC server available with them. Okay. So all this data comes to one OPC server. This OPC server captures the data, and from that particular laptop or whatever that computer is, we have to use a gateway and send this data to the cloud. So you have to subscribe to the cloud. It could be Amazon Web Services. It could be some open source student time limited platforms may be available. It could be Daytona's, Altizon. There are a lot of these cloud services available. Okay. And then this gateway sends this data to the cloud. Okay. And 1 minute. So this data has to be sent to the cloud. Now, there are a lot of OPC gateways available. For example, Kepware has a IoT option now available. Kepware is a PLC based OPC server. Okay, I'll show you the screen of that. But typically, if you see in the slide, on the left hand side, where my mouse is, you have simulation software, you have PLCs, you have SCADA, it could be a real machine. All this data is taken and captured. This has to come to a OPC server. Okay. Now, once the data is captured by OPC server, then there are different types of protocols which send this data to the cloud. It could be a MQTT protocol. It could be a REST gateway. There are these typical terminologies which allow sending this data to a cloud. In this case, MQTT gateway is used and it is sent to a Daytona's Altizon cloud. Okay, then this data goes, and then the same cloud service you have dashboard creation. Okay, so if you go to these cloud services, there are dashboards in which this data which is captured, you can display either as dials, gauges, charts, trends, you want to do counting, etc. So this data is taken, it is represented in a particular format, and that representation, do you want to use view it by using a www website, or you want to send it to a mobile application? From there, you have to decide where you want to send that data. But this entire link works like this. So also another thing is that communication is only one part of the IoT communication. Most of the teachers today are struggling with only the communication part. But the real application is not decided. In IoT, the end result is what is the actual application. You're capturing data and doing what with it? What is the analysis of the data? For example, Eaton has built something known as a live sense cable. It is a line, hydraulic line, and this hydraulic line has got sensors mounted on this line, which calculates the flow and the blockages which happen in this hydraulic line. And this hydraulic line is installed in maybe 2000 tractors and excavators all over the world. And this is sensing all that data. And when it detects that a particular line is clogged, this data is sent to the central, what do you say, the servicing department, and they get to see on the screen that out of these 4000 machines, machine number 5, 6, 7 are showing clogging of the particular line. And we need to send a service engineer there, known as preventive maintenance. What is the end experiment you actually want to do. We are today struggling only with the communication, but we also need to work out what is the actual experiment we need to carry out. Or let's say there is data coming, pistons are working and sending sensor data, and let's say every 10 times the piston is moved, one batch of product is ready, and now we need to create 100 batches. Can this data be represented in that particular dashboard? That is the actual experiment. Communication, any of these companies like Kepware, they'll all help you out. They'll show you how to communicate with this. And one small example, I just want to show you the Kepware server. I'll just share that screen before we end this presentation. Can you see this screen? Can you see the screen, Kepware server?
Yes, sir. Yes, sir. Yes, sir.
Yeah. Now what happens is, in this Kepware server, what happens is, OPC server, this is a typical OPC server with an IoT gateway. Now in this, on the left hand side, there's channel and there's device. Okay. So I set up a channel and a device, and in this device, I've set up tags here, analog 1, tag 2. So I set up these data types. It could be analog 1, 2, 3, 4, Boolean 1, 2, 3, 4, 5, 6. Different types of tags are created here. Okay. Then from Automation Studio, what I do is, using the OPC client, I send data to these tags here. Okay. So this OPC server in Kepware will read these data in these tags here. It is like a data exchange server. After this, on the left hand side here, if you see, there is an IoT gateway in Kepware here. In this IoT gateway, I create a new agent. You'll see there's MQTT, there's REST client, REST server. I create an agent here. Okay. And then to this thing, I add tags here. Okay. In this IoT gateway, I add tags here. So this gateway, which is on the left hand side, okay, can directly communicate to the cloud service. You have to give the addresses of that particular cloud service where you subscribe to. So what I'm trying to tell you is, from Automation Studio, data captured into the OPC server of a software like Kepware, and from Kepware, using the IoT gateway, send it to the cloud, and then use the dashboard of that cloud to show the data representation. That is how the entire channel should work. This is Kepware, yeah. Okay. So that is what I wanted to show you. So this could also be a student project. You can tell a batch of students, please research into this OPC gateway and cloud. And maybe in a matter of a few weeks, they'll build the entire channel of communication. College of Engineering Pune has already done this. But what happens is, people previously are using things like Python scripting. They're using Arduino boards. They're using all these Raspberry Pi. They're doing a lot of these things. But in the industry, that is not how it works. You have to use a professional gateway like either Kepware or Cogent Data Hub. There are a lot of the branded companies who have these data hubs available. Use one of those data hubs. Programming is eliminated in these data hubs. You don't have to sit and write Python programs and a lot of that scripting to connect to the cloud. It can be directly done. So these projects also could be handed over to students. They'll manage all this maybe in a few weeks time, not more than that. Okay, anything else, sir? There's a lot to show, but we are run out of time. It's already 1:25. So if you have any questions, you can ask me now.
Sir, are there any courses to learn Automation Center?
Automation Studio.
Which college you are from?
Sinhagad College, SCOE.
Yeah.
Sinhagad College of Engineering, sir.
Yeah, Automation Studio training we can customize, and we can take it to the colleges as per the need.
Okay.
So we have conducted it to many colleges. Those are intending to deliver it to the students. We have a separate training sessions for faculties also. So depending upon the number of participants and the batch, we decide that how much trainings to be imparted, and according to that, your training sessions can be taken.
Okay.
We had conducted that finishing school training for CA Gardner.
Yeah. That
Kulkarni, sir.
yeah. You, I mean, in CA only, you had some
Okay.
student training program STP. STP was there, under which
Okay.
we had taken 4-5 sessions.
Okay.
Yeah, around 120 students we had
Yeah,
that time.
120 students was there per college. So that session we had taken. So the society was, I mean, it was the mandate of the society, I think.
Okay.
Good afternoon, sir.
Yeah.
Sir, this software is different from MATLAB simulation?
See, sir, MATLAB.
Which is your college, sir?
Sir, UP college, AKT
Yeah.
University, Uttar Pradesh,
Which college?
Rajki Engineering College, Azamgarh, UP.
Rajkiya Engineering College, Azamgarh. What is your name?
Sir, Amit.
Okay, Amit sir, please.
See,
Uh,
number one, MATLAB is not an online simulation tool. It generates graphs which have to be analyzed in offline mode. Number one.
yes,
Second thing is MATLAB has something known as SimScape, SimScape hydraulics pneumatics. If you see the total number of components in that, there are not more than, I would say, we did a rough count, it was around 100, 120. In automations today, we have more than 5,000 such components. Another thing is that a lot of the components are very generic in nature in MATLAB. For example, if you pull out a piston, most of the properties are not available. For example, if you want to put things like, if you want to put, let's say, a small thing like a damping spring, then you have to create another control system, attach it to that particular component. There's a lot of definition you have to do, and you have to be good in control systems to implement the same circuit in Automation Studio. Another thing like temperatures, fluids, viscosity properties, line diameters, lengths, sizing is not there in automation, MATLAB and Simulink. A lot of these things do not exist in MATLAB Simulink. And that is the reason MATLAB Simulink is not even used in the industry for anything to do with hydraulics pneumatics. MATLAB Simulink is okay for development. If you want to develop a particular research component, in which you want to do certain programming and a component level research, then it is used in industry, but industry does not use MATLAB Simulink for system design. There are a lot of limitations and you have to know a lot. For example, I showed you a PID control experiment, right? In MATLAB it will show me mathematical PID control,
yes,
but in the same thing, if I reduce the displacement of the pump, what happens? All these things you can't see in MATLAB. If I put a load on the piston rod, will the PID graph change? I can't see it in MATLAB Simulink. Then you have to be a scientist to put so much of programming into that particular one small circuit in Simulink. So there's a hell lot of a difference. I mean,
sir. Thank you, sir.
yeah.
Yes, please, next.
Every participant want to ask question?
Yeah,
Any
please.
part?
Give your brief introduction first and then please ask your query. Hello. Also, you can put your queries on chat box.
You can raise your hands. If anybody want question, you can raise your hands and you can unmute yourself to ask the question.
Even participants can share their feedback. If they don't have query, they can put the feedback accordingly. We can know that how was the session.
Okay, no questions are there. No any more questions.
Okay, fine. So, shall we wind up?
Okay.
Yes,
So
sir.
Yes.
before that, we should have a vote of thanks. So I'm on the behalf of Siagat Institutes. I'm very much thankful to Mr. Sunil Chowre and Pravin Bell for delivering session on overview of automation studio software. So I hope that all of the participants must have got know and also get to know how they can use the automation studios for simulation of hydraulic pneumatic systems or some mechatronic system like a traffic light control system. Okay, so this software will be definitely useful to teachers as well as the students also. So once again, I will say thank you for all participants and as well as the speakers. Okay. So
Okay,
I
thank you,
declare
sir.
that the session
Thank you
is
very much.
over now.
Thank you.
Thank you, sir.
Okay. Thank you.